Hello, am I audible?
That's correct.
So, hello everyone. I am Manshu. So, in this week, we will solving the question related to trusses. So, we will be solving trusses problem by using the method of joints and method of section. But before coming to trusses, we will solve three questions that we left last week. So, there are two or three questions that we have left last week. Those questions are pretty much tricky, and I left you guys to try to solve some of them which I left. So before starting the trusses, let's complete few more questions of equilibrium and forces, because even in the method of joints we are going to use force balance relation and moment balance relation in the method of section to solve the questions. So let's solve the first one from the last week. So here we have given the three forces which are applied to the bracket and determine the range of values for the magnitude of force P, so that the resultant of the three forces does not exceed 2400 Newton. So we need to find the force P such that the resultant force, which is let's say Fr, does not exceed 2400 Newton. So we need to find the value of P such that this Fr should always remain less than 2400 Newton. So for this, first we know that what is the resultant force, and the resultant force can be written as Fx square plus Fy square. So my Fx is the component of the horizontal force which are acting here, and Fy is the vertical component of the force. So let's say this is my P, this is X, this is Y, this is my 800 Newton, which is at angle 60. So it is at angle 60 here, and this is my 3000 Newton, which is at angle 90 degree from force 800 Newton, which means this angle is 30, this is 90. And now we need to find the component of the forces. So let's say this is my F2 and this is my F3. So this is my F3x and this is my F3y, and this is my F2x, and this is F2y. So first we need to do the force balance in both horizontal and vertical direction to calculate these components Fx and Fy. Then we can actually calculate the total reaction forces. Sorry, resultant forces. And yeah, okay. So if I do the force balance, in the horizontal direction, I will get P plus 800 cos 60 minus 3000 cos 30. So this is my fx and it is non-zero. Similarly, I can write Fy, summation of Fy, which is 800 sin 60 plus 3000 sin 30. And this is my vertical component of the forces. Now, we can write it as, so I can actually calculate this magnitude, which is P. Let me calculate it. So we will get here P minus 2198.07. So this is equal to summation of force in the horizontal direction and the forces in the y direction can be written as 692.82 plus 82 Newton. So this is my force in the vertical direction and this is my summation of force in the horizontal direction. So my resultant force will be P minus 2198.07 whole square plus my vertical component of force, which is 2192.82 का whole square. So this is my expression for the resultant force. Now in the question it is said that we need to find the value of P such that my resultant force will always be less than 2400. So this expression is always less than 2400. So now if I square this expression, I can actually remove the under root from this expression. So I will get P minus 2198.07 whole square plus 2192.82 whole square, which is less than 2400 and x square. So I can bring this part to the right hand side and I will get here. And I can also remove the square. So I will get the quantity in mod P minus 2198.07 mod, which is less than 975.47. So this I will get if I bring this component in the right hand side. Now if I want to remove this mod here, then my limit will look like minus 975.47, P minus 2198.07, 975.47. So basically, if I have a equation which is, let's say, x, and it is less than 2, if I remove the mod, then this x can be negative also. So it will have a limit -2, between -2 and +2. So earlier here it cannot have a negative value, but now since I remove the mod, it can have a equal negative value as well. So therefore the limit will become -2 to 2. So similarly here it has the mod earlier, so it should be less than 975. But if I remove the mod, then my limit is between -975 to +975. So now I can put this in the left and right hand side. So it will be minus 975.47 plus 2198.07 P 975.47 plus 2198.07. So if I do the addition here in both sides, I will here get 1,222.6 Newton and here 3137.5 Newton. So basically it's 1.2 kilonewton and 3.13 kilonewton. So my value of P should lie between 1.2 and 3.13. So my maximum value is 3.13 and my minimum value is 1.2 kilonewton. So this is the force P I required to put here in order for resultant force less than 2400 Newton. So just to recap, first we determine the resultant force, which is Fr, and it's Fx square plus Fy square under root. And we do the force balance to determine the Fx square and Fy square, which are the components of the force. And then we use the condition which is given in the equation, that is should be less than 2400 to determine the unknown force P. So any doubt in this one? Yes.
Cannot we use sine rule for this?
Yes, sorry.
Cannot we use sine rule for this problem?
Well, you can use the sine rule as well. It just still you need to follow the. Still you need to use this expression. But you can use the sine rule to determine the. No, actually here you have given the condition that belongs to the resultant force. So here you need to use the resultant force expression to calculate the force. Because if you use the sine rule, then it should not, I mean, it does not necessarily justifying the condition that we have given in the question. Hello, you have any doubt? So now then we can move to the next one. So here we have given the angle 30 degree and we need to determine the magnitude of force F so that the resultant coupled moment is 100 Newton meter clockwise. So basically, we need to find the moment. We already have given the overall moment, and we need to find the force F. So let's consider the clockwise movement as, sorry, counterclockwise movement as positive, and clockwise movement as negative. And we have given a figure. This is 30. Here we have a force minus F. Which is at 10, so 8 theta. This is my 300 Newton. And I have another unknown force. So let's determine the component of each of these forces. So this will be angle 30. So this is my and this will be 45. So this will be my F sine 45, and this is F cos 45. And here this should be 300 sine 30, and this should be 300 cos 30. Similarly, this should be 300 sine 30, and this is 300 cos 30. So here theta is 30. Here it is F cos 15, and here is F sine. So here I have F15. So this could be my F cos 15 and F sine 15. So these are my component of the forces, and now I can take a movement at about O which is given 100 Newton meter in the clockwise direction. And it is equal to summation of all the moment due to this component of the forces. So it could be written as minus 100, and the radius is 300 meter. So it could be F sine 45 multiplied by 0.3. This is the movement due to this force. Due to this force here, which has the distance 300 meter from point O. Then we have F cos 15 it should be little here actually. F cos 15, and this should be like this. Multiply by 0.3, and due to this component of force as well, this one and this one will create a movement because it has a perpendicular distance of 0.3 meters. So this one and this one will create a movement as well. And the direction of this movement due to this one and this one is same. So I can couple this movement with 2 300 cos 30 multiplied by 0.3. So now I have to solve this equation. So I have 100. Let me solve this one. It will be 0.2 F plus 0.289 F minus 155.884. So if I bring this into left hand side, I will get minus 100 plus 155.88 equals 0.489 F. Which will give me force 114.8 Newton. So just to recap, we have given a disc here, and the total overall moment we have given, which is 100 Newton meter clockwise, and we need to find the force here and here. And for this, we actually take the moment at point O, and from the moment balance equation, we actually calculate the force. So just a short question. So any doubt in this one? If not, then we can move to the next topic.
which is trust.
So first we question we will try to solve problem by using the method of joints, and then we will slowly move to the method of section. So three or four question we will be solving by method of joints. We need to do only the force balance. We will be balancing the force in the x and y direction at each member or at each joint here, and we will calculate the force at each member. And in the method of section, we will divide the truss into two parts, and then we will be using the moment balance equation to calculate the forces at each joint. In the method of section, we will also be use the concept of this method of joint. So we will be using both method of joint and method of section concept to calculate the forces. So in this way, we can quickly analyze the forces at the complicated structure. So first we will be solving relatively simple problems where we have a simple looking geometry of the truss, and then slowly we will move to the little complicated structures. So here we basically the question will be the same for all the cases. We need to determine the forces in the member of truss. So first let's draw a figure here. And we have an applied force here, which is 800 Newton at 20 degree. This is, let's say, my CY, this is my BY. And this is my 0.4 meter, and this is 0.7 meter. And we need to calculate the force at each joint. So first let's consider joint A. So it is always advisable to draw the schematic diagram at each joint. So this is my joint A, and this is B, this is C, and this is the force 800 Newton at 20 degree from the vertical axis. And just to find the component, this is 7, this is 4, this is 7. So first we do the force balance analysis in the horizontal direction. So here we will get minus 800 sine 20 minus AB, and we need to find in the horizontal direction. So if this is my 4 and this is 7, then this will be 65. So in the horizontal direction it will become 7 by root 65 plus AC 7 by root 65 equal to 0. So this is my equation 1. And then I can do the force balance in the vertical direction. And the summation of force is 0. So in the vertical direction I will have minus 800 cos 20 minus AB 4 by root 65 minus AC 4 by root 65 equal to 0. And this is my equation 2. Now we can see that we have two equations and we have two unknowns. AB and AC.
So
So we can find the force AB and AC from this two equation.
So
So let me simplify this equation as here. So let me calculate it. So here we have sine 20 minus 273.616 minus 0.868 AB plus 0.868 AC equal 0. And in the second one, we have so this is my equation 1, and in equation 2, we will have 751.754. Here we have minus 0.496 AB minus 0.496 AC equal to 0. And it's the same second equation. Then we can solve this too. So I'm writing, when you solve this too, I will write the direct answer here. So we will have AB, which is 905 Newton compression, and AC, which is 600 Newton, just compression. The compression, because you will get in the minus sign, so either you can write the compression and magnitude, or you can write with minus sign. So you get the force here, you get this force in this member and force in this member. Now we need to find the force in the member BC, this member. So now we can take joint C. So we have here C, B, and here you have A. And the direction are 4, 7. And now if you do the force balance in the horizontal direction, you will get minus BC and minus 7 by root 65 AC equals 0. And we already know the AC, which is 600 Newton, and it's minus, because it's compression, so it's minus 600 Newton. So we will get BC as 600 divided by 8.06, which is 521 Newton in positive and at tension. So at member BC, we have 521 Newton, and at the other members, we calculate the force by solving equation 1 and 2. So overall in the method of joint, you need to do the force balance at each joint to calculate the force at each member. So this method is easy, but it's little time consuming method. So any doubt in this? If not, we can look more examples of it.
So
So
here
here
also we
also we
need to
need to
calculate
calculate
the
the
force
force
at.
at.
Okay.
Okay.
So
So
here we
here we
need to
need to
find the
find the
calculated
calculated
force
force
at
at
uh,
I
thing in
think in
all the
all the
members.
members.
Okay,
Okay,
let's
let's
calculate
calculate
at
at
all.
all.
So
So
here
here
P1
P1
is
is
2
2
kilonewton
kilonewton
and
and
P2
P2
is
is
1.5
1.5
kilonewton.
kilonewton.
And
And
first
first
let's
let's
consider
consider
this
this
joint
joint
C.
C.
So
So
here
here
we
we
selected
selected
joint
joint
C
C
because
because
it's
it's
pretty
pretty
easy to
easy to
calculate the
calculate the
forces
forces
here
here
in
in
this
this
joint
joint
because we
because
have
we have
only
only
we
we
need
need
to
to
take
take
into
into
account
account
only
only
three
three
forces.
forces.
So
So
let's
let's
do
do
force
force
balance in
balance in
the
the
x
x
direction,
direction.
and
And
here we
here we
have
have
CD
CD
minus
minus
CB
CB
cos
cos
30
30
degree,
degree,
which
which
is
is
0.
0.
So
So
this is
this
my
is my
equation
equation
1.
1.
And
And
when we
when we
do the
do the
force
force
balance,
balance,
the
the
y
y
direction,
direction,
we
we
will
will
have
have
minus
minus
P2,
P2,
which
which
is
is
1.5,
1.5,
and
and
plus
plus
CB
CB
sine
sine
30
30
equal
equal
to
to
0,
0,
which is
which is
equation
equation
2.
2.
So my
So my
CB
CB
will
will
be
be
1.5
1.5
divided
divided
by
by
sine
sine
30,
30,
and
and
it
it
be
be
sine
sine
30 is
30 is
half,
half,
so my
so my
CB will
CB
be
will be
3
3
kilonewton.
kilonewton.
So
So
now I
now I
can
can
put
put
this
this
value of
value of
CB in
CB in
equation
equation
1.
1.
So I
So I
will
will
get
get
CD
CD
equals
equals
CB
CB
cos
cos
30,
30,
CD
CD
equals
equals
3
3
cos
cos
30,
30.
and if
And
I
if I
solve
solve
this, I
this,
will
I will
get
get
CD
CD
equals
equals
2.6
2.6
kilonewton.
kilonewton.
So
So
here
here
we
we
have
have
identified the
identified the
force
force
in
in
CB
CB
and
and
CD.
CD.
Now
Now
consider
consider
joint
joint
D.
D.
So
So
at
at
joint
joint
D we
D we
have
have
force
force
P,
P,
P1,
P1,
force
force
P1,
P1,
this
this
is
is
T,
T,
this is
this is
C,
C,
this
this
is
is
E,
E,
and
and
this is
this is
B.
B.
And
And
it is
it is
pretty
pretty
straightforward
straightforward
here
here
again.
again.
So
So
taking the
taking the
horizontal
horizontal
force
force
component
component
first,
first,
we
we
have
have
ED
ED
minus
minus
CD
CD
equal to
equal to
0,
0
because
because
only
only
these
these
two
two
forces
forces
are
are
there
there in the
in a
in a
horizontal
horizontal
component,
component.
so it
So
will
it
be
will be
equation
equation
1.
1.
And in
And
the
in the
vertical
vertical
component,
component,
we
we
will
will
have
have
minus
minus
P1
P1
plus
plus
BD.
BD.
And we
And
know
we know
P1,
P1,
which
which
is
is
minus
minus
2
2
plus
plus
BD
BD
equal to
equal to
0.
0.
So
So
BD
BD
is
is
2
2
kilonewton.
kilonewton.
And we
And we
already
already
found the
found the
force
force
CD.
CD.
So
So
here we
here
will
we will
get
get
ED
ED
equals
equals
CD.
CD. and we found CD as 2.6 kilonewton. So the force in ED also is 2.6 and force in member BD is 2 kilonewton. So we have found the force in BD and ED also. Now let's take the joint at B. And here we actually aligning our coordinate system like this. This is my x-axis and this is my y-axis. And this is 60 degree. This is 90. This is y and this is my x component. So this will be 30 and this will be 30. So if I do the force balance here, at the x direction, so here I have EB sine 30 plus BD sine 30 plus CB minus AB equal to 0. This is my equation 1. And in the vertical direction, I have a force in this component. So it is acting along this green line. So first, my AB cos 30 plus DB cos 30. DB will be minus, which it's acting opposite, equal to 0. This is my equation 2. And the unknown force is here, EB. Let me write this BD. And EB is also unknown force. So from equation 2, I can write EB equals BD. And we know BD is 2 kilonewton. So my EB is also 2 kilonewton. And then we can use equation 1. Here we have EB, which is 2 kilonewton. BD is also 2 kilonewton. And CB is 3 kilonewton, which we found equal to AB. So it will be 4 sine 30 plus 3 equals AB sine 30 is half, so 2 plus 3. So AB will be 5 kilonewton. So we found the force AB and EB. So AB and EB. So we have found forces in all the members by using method of joints. So first we consider different joint here. First we considered C and then D and then B, and we use the force balance in all these joint to calculate the forces here. So it's pretty much straightforward. It's just little time consuming. So any doubt here?
Now
Now
then we
then we
can
can
move
move
to
to
the
the
next
next
question.
question.
So
So
first
first
we
we
will
will
solve
solve
this
this
question
question
and
and
then
then
we
we
will
will
come to
come
the
to the
previous
previous
one.
one.
So
So
here
here
we
we
need to
need to
actually
actually
calculate
calculate
the
the
zero
zero
force
force
member in
member
the
in the
given
given
truss.
truss.
So
So
basically we
basically we
can
can
also
also
find the
find the
zero
zero
force
force
member
member
by
by
inspection
inspection
alone.
alone.
For
For
example,
example,
let's say
let's
we
say
have
we have
given a
given a
truss.
truss.
So
So
this
this
is
is
we have
we
a
have a
joint
joint
here,
here,
and
and
this
this
is
is
we have
we have
given a
given a
system
system
at a
at a
joint,
joint,
let's say
let's say
A.
A.
And in
And
this
in this
system,
system,
the
the
force in
force in
this
this
member will
member
be
will be
zero.
zero.
So
So
by
by
method of
method of
inspection,
inspection,
just we
just we
can
can
check
check
which
which
of
of
this
this
joint
joint
actually
actually
resemble
resemble
this
this
kind
kind
of a
of a
system
system
here.
here.
And we
And we
can
can
actually
actually
conclude
conclude
the
the
zero
zero
member.
member.
So
So
here
here
at
at
G we
G we
can
can
see
see
that
that
it
it
actually
actually
resemble
resembles
this
this
kind of
kind of
a
a
figure.
figure.
Hello,
Hello,
you have
you have
a
a
you have
you have
any
any
question?
question?
FD.
Yeah.
Yeah.
FD also looking like that.
Yeah,
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 yeah.
yeah.
Remember?
Yes,
Yes,
yes.
yes.
So
So
here
here
this
this
joint
joint
and
and
this
this
joint,
joint,
we have
we
a
have a
configuration
configuration
like
like
this.
this.
So we
So
can
we can
actually
actually
uh,
uh,
we
we
can
can
actually
actually
conclude
conclude
that the
that the
force
force
in
in
this
this
member
member
GC
GC
and in
and in
this
this
member
member
FD
FD
are
are
zero
zero
member.
member,
So
so
that we
that we
can
can
look
look
by
by
the
by the
equation
equation
as
as
well.
well.
So
So
for
for
example,
example,
let's
let's
say
say
this is
this is
my
my
joint
joint
G
G
F,
F,
and
and
this
this
is
is
C.
C.
So
So
when we do
when
the
we do
force
the force
balance in the
balance
y
in the y
direction,
direction,
we will
we
have
will have
only
only
force in
force
the
in the
GC
GC
member,
member,
and it
and
is
it is
equal to
equal to
0.
zero.
No
No
other
other
vertical
vertical
forces
forces
are
are
there.
there.
So
So
we
we
can
can
conclude
conclude
GC
GC
force in
force
the
in the
GC is
GC is
0.
zero.
Now
Now
similarly, if
similarly, if
we
we
draw
draw
the
the
joint
joint
D,
D,
and
and
this is
this is
my
my
joint
joint
F.
F.
And
And
now
now
here I
here
am
I'm
using the
using the
coordinate
coordinate
system
system
incline
incline
along
along
CA.
CA.
So
So
even
even
at
at
joint
joint
D,
D,
if
if
I
I
do the
do the
force
force
balance in
balance
the
in the
vertical
vertical
direction or
direction
in
or in
the
the
direction
direction
of
of
Y,
Y,
I
I
can
can
get
get
FD
FD
equal to
equal to
0
zero
because there
because
is
there is
no
no
other
other
forces
forces
in the
in the
Y
Y
direction.
direction.
And if
And
I
if I
do in
do
the
in the
X
X
direction,
direction,
I will
I will
have
have
CD
CD
minus
minus
ED
ED
equal to
equal to
0, and
zero,
I
and
will
I will
get
get
CD
CD
equal
equal
to
to
ED.
ED.
So
So
basically
basically
FD
FD
equal to
equal to
0
zero
here.
here.
So
So
now
now
let's
let's
consider
consider
this
this
part of
part of
the
the
joint.
joint.
So
So
here we
here
have
we
a
have a
2
2
kilonewton
kilonewton
force
force
at
at
P.
P.
Here we
Here we
have
have
A.
A.
Here we
Here we
have
have
C.
C,
And
and
this
this
is
is let's say this is my H. So now if let me align the coordinate system as well. So this is my X and this is my Y direction. So if I do the force balance in the Y direction, I will have H minus 2 equal to 0 BH, and you can see here the force in the BH member is not 0, it is actually 2 kilonewton. And on doing the force balance in the X direction, I will have AB equal to BC. So you can see if we have given a cross joint which looks like this, then the force in the vertical member is 0, but only criteria is there should be no external force like here. So here we have external force which is 2 kilonewton, which is acting at this cross joint. So the force in this member in BH, so this is my B. So force in this member BH will not be a 0, but if there is no external member like here and here, then in the cross joint the force will always be a 0. And if let's say instead of G you actually choose point C, then what happened? When you choose point G, you found that the force in this member is 0. But if you choose point C, then there will be a various members here, and it is very difficult to evaluate the forces. You already evaluate the force in this member which is 0, which means that all the force which is applied by 5 kilonewton will be distributed in the remaining process, but not this one, because force here will be 0. So even by method of inspection, just always consider multiple joints before concluding that the force is 0. Because if you choose joint C at the first place, then it will be really confusing. But if you choose joint G, then you can easily verify it is 0 member force. So any question?
What about the F joint? At a joint F, there is no external forces acting.
Yeah. So let's consider
Joint also GF, zero force member, or
so we can consider that joint now. You can check if it is 0 or not. It should be 0, I guess. So let's consider joint F. This is F, this is G, and this is E. This is D, and this is C. Let's say it have an angle theta from the vertical direction. So now if I do the force balance here, so my coordinate axis is X and Y. I do the force balance in Y direction. So I will get here, and let's say this is my angle alpha. So I will get F. You have any question?
I think, as you said, FD is a zero force member.
It's a 0 force number. So we will see this.
But you are taking here again FD.
I mean just for complete writing the equation in a complete manner I am just considering here. So I will get here, FC cos theta, and here is plus FT sine alpha equal to 0, and as you have identified, as we have calculated before, this FD is 0, it's a 0 force member, so we will left with FC cos theta equals 0. So here we will get FC 0 as well. So force in the FC is also 0. So now we have three members which have a 0 force, which is FC, FD and GC. So this is the answer. So overall three members are there. So just choose the joint which don't have any external point and try to do the force balance in those joint, and then you can actually identify the 0 force member. And by inspection you can easily identify the 0 force if you have a cross members like this. So in the vertical one it will be force will be 0. So this is by inspection, but it's always better to choose those joints like G, F, T, where the external forces are not there. So in those cases, you may find the 0 force member. So any other doubt? So if not, then we can move to the next question. So this will be the last question that we will solve by method of section. And after that we will be using method of joint. And after this we will be using the question which we solve by method of section. So here we need to determine the forces in all the members, and we have given the weight of this, which is 900 kg. So let's first determine the angles here. So we have given 40 degree of angle D from the horizontal axis. We can actually find the angle BAC, which will be cos theta 12 by 5. Sorry, 13. 12 by 13. So here we will have theta, which is 22.6. So this is my 22.6 degrees. This is, and then this angle will be 22.6 plus, let's say this is x angle, x degree plus 90 equal to 180. So here we will have 180 minus 90 plus 22.6, and x will be then around 60. It will be around 67 approximately. $67.4. Similarly, we can, so this also will become 22.6. So since this is my 40, this will become 67.4. This will be 50, and we can find this angle from 90 equals 40 plus 22.6 plus some unknown angle, let's say y degree, and we will get y as 27.4. So now we have little ideas about angles here. we can actually consider each joint. So first consider joint A. This is joint A. This is 27.4. This is 22.6. This is 40. And this is B. This is C. And this is the weight, which is 900 multiply 9.81 Newton. So let's do the force balance analysis. So let's balance the force in the x direction. So my AB will be, so the direction of force is given here, and my AB can be written as cos 40 minus AC, and I can take the component of AC using this angle 27.4. So it will be sine 27.4 equal to 0. So this is my equation 1. And if I do the vertical force balance, then I will have minus 900 multiplied by 9.81 minus AB sine 40 minus AC cos 27.4. We just need to focus in this schematic to get the components. So we can write down equation 1 and equation 2 now,
and we can solve this equation
together. So if you solve this together, you will get
so
from equation 1, you have 0.766 AB minus 0.46 AC equal to 0. So AB will be 0.46 AC by 0.766. So it will be so I can write AB as minus 0.6 AC. So now I can substitute this expression in equation 2. So here I have minus 8.829 kilonewton. So I am writing in the kilonewton. So this is this 8.829 in kilonewton. So I can write AB in terms of AC here. So it will be plus 0.6 AC sine 40. So this could be this could be 0.0418 AC minus 0.88 AC equal to 0. So I will get 8.829 equals minus 0.8468 AC. So my AC will be 10.43 kilonewton, and AB will be 6.25 kilonewton. So if anybody is solving, we can check if you are getting the same answer. So we identify the force in AC and AB. So let's consider joint C. You have here C, A, B, and here you have B. This is D. And this is the angle 27.4. This is 40. This is 50. And the overall angle is 90. So now you do this, repeat the same exercise, force balance in the horizontal component. So if you consider the horizontal one, you can write minus CB cos 50 minus CD, this one, and I will consider 40 here, so it will be cos 40, and then plus CA sin 27.4 equal to 0. This is my equation 1. And if I do the force balance in the vertical direction, I will have, so this is CB sin 50 minus CD sin 40, and this is plus CA, which is cos 27.4 equal to 0. So this is equation 2. And the unknown forces here are this one and this one, CD. We already know CA. We already know force CA. So if you solve the equation 1 and 2, you will get CD as minus 60. hand it out.
CB arrow direction is upwards. Why you are taking the negative?
Because this is CD. So
in
in
the
the
CB. I am asking
CB.
CB,
BC.
okay, okay.
BC.
So this is your BC here,
and
and
then
then
this
this
will be
will be
the
the
y
Y
component,
component,
and
and
this will
this
be
will be
your
your
x
X
component.
component.
So
So
you are
you are
going
going
negative
negative
x
X
here,
here,
and you
and
are
you are
going
going
positive
positive
y,
Y,
which
which
is
is
positive,
positive,
and the
and the
negative
negative
x.
X.
Okay. Got it.
Yep.
Yeah. Okay.
And
And
CB
CB
will
will
be
be
6.76
6.76
kilonewton.
kilonewton.
So
So
just
just
need to
need to
solve
solve
this
this
question
question
1
1
and
and
2.
2.
So
So
we have
we have
CD
CD
and
and
CB
CB
here,
here,
which
which
means
means
we
we
have
have
this
this
CD
CD
and we
and we
have
have
this one
this one
CB.
CB.
And the
And the
only
only
member is
members
left is
left is
now
now
BD.
BD.
So we
So
can
we
now
can now
consider
consider
joint
joint
BD.
BD. Mm, mm,
Or
or
let's
let's
consider a
consider a
joint
joint
D
D
because
because
it
it
is
is
much
much
easier
easier
if we
if we
consider
consider
joint
joint
D.
D.
Because if
Because
we
if we
consider
consider
joint
joint
B,
B,
then
then
there
there
will
will
be
be
some
some
force in
force in
this
this
rope
rope
T.
T.
Then
Then
there
there
will
will
be
be
multiple
multiple
members
members
like
like
BD,
BD,
BC,
BC,
and
and
BA.
BA.
We
We
need to
need to
consider
consider
all
all
these
this
member of
member of
forces.
forces.
If we
If we
consider
consider
joint
joint
D,
D,
this is
this is
my
my
reaction
reaction
dy.
dy,
We
we
only
only
need to
need to
consider
consider
two
two
members.
members.
One
One
is
is
this
this
BD
BD
and
and
another
another
is
is
DC.
DC.
And we
And
know
we
the
know the
angles as
angles
well.
as well.
So
So
DC
DC
is
is
40
40
from
from
horizontal
horizontal
and
and
DB
DB
is
is
22.6
22.6
from
from
DC.
DC.
So
So
let's
let's
consider
consider
joint
joint
D
D
here.
here.
So
So
this
this
is
is
D,
D,
this
this
is
is
B,
B,
and
and
this
this
was
was
C.
C.
This is
This is
at
at
angle
angle
40,
40
and
and
this
this
is
is
at
at
22.6.
22.6.
So the
So the
overall
overall
angle
angle
will
will
be
be
62.6.
62.6.
Hello?
Hello?
So
So
we
we
can do
can
the
do the
force
force
balance in
balance
the
in the
x
x
direction.
direction.
So
So
it
it
will
will
be
be
minus
minus
BD
BD
cos
cos
62.6
62.6
minus
minus
CD
CD
cos
cos
40
40
equal
equal
to
to
0.
0.
So
So
BD
BD
equal
equal
to
to
minus
minus
CD
CD
cos
cos
40
40
divided
divided
by
by
cos
cos
62.6.
62.6.
So
So
and
in
CD we
CD we
calculate
calculate
16.2.
16.2.
So
So
it's
it's
16.2
16.2
point seven six six
0.766
point four six.
0.46.
So
So
my
my
BD
BD
will
will
be
be
0.46 26.97 kilonewton. So, any issue in this question? We have calculated the force in all the members by using method of joints. So it was a little tricky. It was the last question that we have solved by using method of joints. So I put little tricky one because here we need to calculate a lot of angles before we solving the question, and then we can choose the suitable joint to simplify the overall calculations. So in the last I chose joint D instead of B, and we use the force balance in all the joints. Hello, you have any doubt?
Yes, sir. One doubt. When you are taking the point D, the arrow direction for the member BD, you are taking towards the point D.
Yeah, because because we have a normal reaction which is there we are applying at point D, and this normal reaction is in the positive y direction. So to counter balance that normal reaction, I'm applying the we are, we are applying the force in opposite to that direction.
I am asking for the member point BD, sir.
Yeah, in BD
Where
also.
taking?
So here BD, since there is a normal reaction in the positive y direction, in order to counterbalance this, I am considering the BD force opposite to the normal reaction, which is in the negative y direction. Component of BD will be in negative y direction. And also,
Okay, sir. Thank you.
okay. So let's move to the next question. So here we need to find the forces in the member. HD, CD, and GD, and we will be using method of section to solve this problem. So in order to use a method of section, it is always advisable to first calculate the normal reaction forces at the joint, because when we in the method of section what we do, we actually divide the truss into two parts. So we actually divide the trusses into parts. This is my first part and this is my second part, and then we actually do the moment balance analysis in either of this part. So in order to do the moment balance analysis, first always calculate all the forces which are there. So for example, the force normal reaction force at A, calculate the normal reaction force at A and divide the truss in such a way that it actually cut at most three members. So here we cut this member, this member and this member. So now we can actually, by using the method of section, we can actually calculate the forces in this members. So we actually try to cut at most three members because to solve the forces at each member, we require separate equation. So we use force balance in the horizontal direction, force balance in the vertical direction, and we use the moment balance equation. So at most we can use three equation to solve for the forces. So for this region we actually try to cut at most three regions, because if we cut in such a way that it can crossing more than three members, like here it is crossing five members, then here you actually need to solve five equation, and that is we cannot do because we have only at most three equation to solve the unknown forces. So in the method of section we actually try to cut at most three members, and then we do the moment balance analysis. So let's first calculate the normal reaction forces at the end of joint. So let me take the moment at A, and I am considering the counterclockwise movement as positive and clockwise movement as negative. So if I take the moment at A, then this is my EY, and it has the movement in the counterclockwise direction about point A. So it will be EY multiplied by 16, and this is all clockwise movement about point A. So all this will be negative. Minus 20 multiply 4 minus 20 multiply by 8 minus 40 multiply by 12 equal to 0. So on solving this, I will get my normal reaction EY equals to, let me solve by getting the same. So this is 80, this is 160, this is 480. Yes, so I will get EY as 45 kilonewton. Now once you actually determine the normal reaction, now you can cut the members. So we need to determine the forces in HD, this one, CD, this, and GD, this one. So we cut the truss like here, and we cross to three members, GH, HD, and CD. And let's say this is my part 1, this is the remaining part, and I am only considering this region of the truss. So first let's consider the movement at around point H. So it will be summation of movement at H equals to 0, and the movement will come, and we need to assign the direction of forces as well. And my direction of forces, let's say this. So as of now I am assigning in an arbitrary direction, and at point H, and this is my, so each triangle I have a 45 degree at the base, and at the top also 45, 45, and this is 90. So the movement will come due to this force, 40 kilonewton force, and force CD, which is at 4 meter distance, this one, and due to force EY, this. So my EY will be counterclockwise direction, so it will be plus 45, which is my EY, multiply by 8, then force CD, which is my clockwise direction around H, and it will be minus CD multiply by 4, and 40 is also going clockwise direction. Equal to 0. So my CD will be here 360 minus 160, and it is 50 kilonewton. So my CD is 50 kilonewton. Now I can take a movement at or I can do the summation of force in the y direction. So the vertical component of the force that I have is EY 40 kilonewton, and the component of this HD. So this is my force HD, and the vertical component will be this. This is my HD, this is my HDY, and this is my HDX. Will be sine 45 plus 45 minus 40 equal to 0. So my HD 0.707 plus 5 or equal to minus 5, then HD will be 7.0721 kilonewton. So this is my HD and this is my CD. So now we need to find the GD. So we can now consider the method of joint. At joint D. So I have here D, this is my C, and this is G, and this is my H 45, and I can do the summation of force in the y direction, and I will get DG minus HD sine 45 equal to 0, and my HD is 7.07, and sine 45 will be 0.707 equal to 0. So my DG will be 5 kilonewton. So now we have used the method of joint to calculate the force in the GD, because you can see we have not cut this member. So we can use the method of section where we have cut the members. So we have not cut the GD members. So here we have used the method of joint to calculate the forces, and for to calculate the force HG, we we have used the method of section because we have cut the member HG. Now, similarly, in order to calculate the force at CD, we use the method of joint to calculate the force at CD. And we can also use the method of section to find the force at GD. So any doubt in this question?
Sir, how did you assign the direction, sir? CD direction and HD, HG.
So as of now, I assign the direction randomly. So if you do the moment balance or the force balance analysis, you will actually get the direction. So if you get the minus direction, then you can correct your previous direction. So for example, let's say I assign this is my A, this is my B, this is C, and this is a D, and I assign this direction like this. Let's say you get AB as -2, so you can actually modify the direction into this. Initially, I assign in some random manner.
Okay, sir. Thank you.
So let's solve another question by using the method of joint. And here we need to calculate the force at BC, CG, and GF. This one, and this one. And when we use the method of section, we can actually cross this section, and we can actually cross three members which are unknown, which we have yet to calculate, and then we can assign the direction. In this manner, and here we need to calculate AY and EY first. So if I take the moment along E, then I can actually calculate AY, and I can only focus in part 1, which is this part of the section. So that's my CC counterclockwise movement is positive. So if I take moment at point E, I will get, so this is my clockwise movement, so I will get AY minus AY multiplied by 9. This is counterclockwise around E, so it is plus 6 multiply 6 plus 8 multiply 3 equal to 0. So my AY will be 6.66 kilonewton. So in order to find the forces, let's consider the moment at point C. And you can see the sides of this triangle are equal. So this is the equilateral triangle. So this will be 60, this will be 60, and this will also be 60. So if I want to take the moment at C, then the moment will be coming due to force AY due to 6 kilonewton, this one, and due to the force FG or GF. So these three forces actually creating a moment along point C. So my AY will be in the clockwise direction in the at about point C. So it will be minus AY. This is my distance from AY. So which is 3 plus 1.5. This is 1.5 and this is 1.5. So it will be 4.5. And due to 6 kilonewton, which will be counterclockwise direction. So it will be 6 plus 6 multiplied by 1.5. And due to the force GF, which is again in the counterclockwise direction around C. So if this is my 3 meter and this is 60 and this is 1.5 meter, then it will be 1060. So or I can write this as 3 sine 60. So this distance is 3 sine 60. And GF is counterclockwise. So plus GF 3 sine 60 equal to 0. And my AY is 6.66. So it will be minus 30 plus 9 plus 2.598 GF equal to 0. Minus 21, it will be plus 21 equal to 2.59 GF. So my GF will be 8.18 kilonewton. So we identify the force here. So if I do now the force balance in the y direction, then I can actually calculate force in this member, because we will consider the force in the y component. So when we do the summation of force in the y direction, I will have a force AY minus this 6 kilonewton minus this force, component of this force, which is GC sine 60. And AY is 45 minus 6 minus GC sine 60 equal to 0. So it will be GC 39 sine 60. My GC will be 45.34 kilonewton. Sorry. My AY was 6.66, right? Sorry. This is 6.66. So it will be 0.66. So it will be around GC equal 0.7 kilonewton. So here we got force here in this member. Now to calculate the force in this member, we can either use the method of section, and we can actually take the moment, let's say at around this point, which is F, or we can actually do the force balance in the x direction. So let's take the movement, because there is no there is only one force in the x direction, and that is due to this member GC in the x direction. Yeah, we have all this also, GF. But let's do the moment analysis, moment balance. We take the moment at about point F, and we will have a force due to BC, which is going in this direction, counterclockwise direction. Then force AY, which is going clockwise. And then this force CG. And the vertical component of this force CG will be going in the counterclockwise direction. So let's take the moment at about point F. So we have AY multiplied by 6. Then we have BC, and it is going counterclockwise. 3 sine 60. This is the normal distance. And we have CG, vertical component of a CG. Which is CG sine 60 plus CG sine 60 multiplied by 1.5 equal to 0. So 6.66 plus 6. Will be 2.6 BC plus, in GC we got 0.7. It will be 0.909 equal to 0. This is 40. 0.909 equal minus 2.6 BC. So BC we will get around 15.7 kilonewton. So we identify the force in BC as well. So any doubt?
Yeah. Method of section, that we are taking moment about any point, any joint. This problem we are find out moment about point F or point C.
I mean, you can choose any movement in the vicinity of this where you apply the method of section. It's
There are only 3 members we are considering.
yeah. So you can actually consider C, you can consider G, you can consider F, or you can consider B.
Any point we will take.
So this is actually you have to inspect if you take the movement, let's say around B, what are the forces which are causing the movement? You have to check that. And once you get the list of forces which are acting, which are causing the movement,
So when you are finding out that moment about any point, we are considering those 3 members and reaction forces only. Excellent, sir. Am I audible, sir? Excellent, sir. Am I audible? Excellent, sir. I have one doubt in this problem.